In this and several other lessons, we'll answer the question, how should we study? And one of the ideas here is that knowing how memory works can help maximize learning. So there are several things we need to know about our brains and the learning process if we want to succeed as learners. First thing we need to know that paying close attention during learning is critical. Now, we've learned about these two important memory systems in the brain, the working memory system and the long-term memory system. And we said that the working memory system has a limited capacity, so therefore the brain has an attention system that controls what it is that enters working memory. There is just so much information that is entering our brain through our senses that the brain has to be selective in which stream of information gets further processing resources. So the attention system is controlling what enters the working memory system, and as a consequence then, what can be stored in the long-term memory system. So attention is the gateway to the working memory system. And so if we're not paying attention, if the information is not getting into the working memory system, we're not going to store that information well in our long-term memory system. And if we have poor storage in the long-term memory system, we're going to have poor retrieval. So attention is critical in the learning process. We should also know that repeating study sessions increases the strength of memory traces in our long-term memory system. You'll recall we used an analogy of a computer. The RAM would be the working memory and the hard drive would be the long-term memory system. But in a computer, see, the idea is that all the information stored on the hard drive is sort of stored with the same strength, as it were. It's stored as a sequence of zeros and ones, bits of information. But it's not like there are bits of information that are stored strongly and other bits of information stored weakly. All the information is stored with the same strength. That's not true of brains. So memories can be stored with different strengths in this biological tissue we call the cerebral cortex. And we now know the idea is that memory strength is related to synapse strength. So let's say we've got some neurons in the cerebral cortex. So this is just a pair of neurons, the same pair of neurons in this diagram. After the first study session, we might increase the strength of that synapse a little bit. We study a second time, and the synapse grows a little bit more. Third study, fourth study, fifth study, and we've got a really strong synapse between those two neurons. So the idea is, with only one study session, we have a weaker memory trace, but if we study repeatedly, we have a chance of growing this synapse stronger and stronger, and that would be a stronger memory trace. So with repetition, we can make memory traces stronger. Back to our diagram, then every time we study the same information repeatedly, we're giving our brain the chance of building stronger and stronger synapses among those neurons that are storing that information. So repetition allows for more and more biological growth in those synapses that are representing that learned information, and we will make stronger and stronger memory traces for that information. We should also know that spacing study sessions with sleep allows for multiple rounds of memory consolidation. So back to our diagram, when we engage in the first study session, we will make some progress in strengthening the memory traces there. But then when we go to sleep, the brain really does some important work. It's going to fire up the hippocampal memory traces for the day's learning, and that activity will strengthen the cortical memory traces. So consolidation during sleep is how the brain really strengthens those cortical memory traces. So spacing out multiple study sessions allows us then to get the multiple benefits of consolidation. So if we study multiple times with sleep in between, we're going to get repeated consolidation during sleep, which will lead to stronger and stronger memory traces, and then we'll have greater success trying to retrieve that information at any time in the future. We also should know that there are some study techniques that are better than others, so we want to use the recommended study techniques. And one of those we said was this idea of deep processing. Some study techniques involve more brain activity, and the more widespread activity in the brain you're using when you're using a study technique, then the better the chance of storing that information and retrieving it later. So we're going to say deep processing techniques lead to stronger memory traces in our long-term system. We did some experiments looking at the effect of different mental tasks on word recall, and we identified that counting syllables was a shallow task in comparison to evaluating pleasant or unpleasant. We saw the memory advantage for that type of mental task, so we would say that task was deeper processing than syllables. And likewise with writing versus drawing. Drawing is deeper processing than writing. It leads to a memory advantage. So in addition to deep processing, we want to use retrieval practice in our study strategy. Retrieval practice is just calling information to mind. And ideally, we want to be trying to get the information out of our long-term memory system. So retrieval practice, then, we might succeed or we might fail. And that's useful to us because that will tell us what we know and what we don't know. That's our metacognition then. So importantly, we want to test ourselves after a delay so the working memory boost disappears, but that will ensure that we're testing the long-term system. And if we're successful at retrieving information, well then we can conclude that we might have relatively strong memory traces for that information. But if we fail to retrieve, then we can conclude that we have relatively weak memory traces for that information. So retrieval practice gives us a way to test the strength of memory traces in our long-term memory system if we are testing ourselves after a delay or after sleep. So retrieval practice improves our metacognition. In addition, retrieval practice forces the brain to search for the desired information. And so this has the effect of strengthening the retrieval pathways. And this is the brain's search mechanism. So these are systems that have to be exercised. We not only need to make strong memory traces, but we need to give the brain practice finding those memory traces. And retrieval practice does exactly that. In addition, every time we seek information and reactivate a memory in the long-term system, then load it up into the working memory system, that activated memory trace then goes through another round of consolidation during sleep. So when we retrieve information, we're giving the brain another chance to strengthen that memory trace during sleep, during memory consolidation. So retrieval practice will be triggering another round of consolidation, making the memory traces even stronger than they were. So we've got these 4 good study techniques over here. We want to use techniques that are deeper processing. We want to repeat our study sessions. We want to space out our study sessions, and we want to use heavy doses of retrieval practice. All of those will help us build strong memory traces in the long-term system. In addition, the retrieval practice helps to strengthen the searching systems so we can find those memories that we want. So this is the picture of what good study techniques look like. We want to use techniques to build strong memory traces and also practice accessing that information with retrieval practice. Finally, we don't want to be cramming. Now, cramming immediately before a test makes use of the working memory boost, and we said that was a temporary increase in synapse strength, making information more accessible. So whenever we're studying some information, the neurons involved in processing that information enjoy a temporary increase in synapses, and so that information is easily retrievable for a short time right after the study session. So that's sort of a benefit. We'll call that the working memory boost. The problem is that because cramming sort of by definition is just you're studying once, right before an assessment, you might pass the test, but you're going to be left with weak memory traces in your long-term memory system, right? So you've only got one learning or one study session. You haven't had a chance to go through multiple rounds of consolidation, with multiple study sessions. So you're going to be left with weak memory traces. And as a consequence, fast forgetting. You'll have poor long-term retrieval if you just cram. At the level of synapses, then, the idea is that cramming is going to leave you with relatively weak synapses, so weak memory traces. If you study repeatedly with sleep in between, so you get the consolidation, you can have really strong synapses and strong memory traces that can be accessed easily over time. So for the poorly educated brain, this is a brain with weak memories. And weak memory traces will lead to fast forgetting. Cramming leads to ignorance. For the educated brain, we're going to have a brain filled with strong memories. But getting an education requires mental work and discipline. We want to use the best study strategies known to science, and we've got to be disciplined in using them.